Hi everyone. This is more examples of 2.2, and so we're going to give a try to them. And so here's the paper view for the more examples of 2.2. I kind of had started this video, so I have one arrow drawn, but I hadn't even thought about what I was going to label that arrow when I realized that I wanted to make a guess at what something was. And so I wanted to use a coin. And so I had to stop the video and start all over to go get a coin. So the graph of the function f and its derivative f prime are shown. Which is bigger, f prime at -1 or f double prime at 1? And the first time that I saw this question, there's three of them, 45, 46, and 47. And out of your textbook. The first time I saw the question, I have to admit, I read it like 3 times. And then I finally realized, okay, the first thing you have to do is decide which one's f and which one's f prime. And so that's what we're gonna do. It's actually a little easier on 45 to determine which one is which, and but the same technique. I'm gonna show you the technique, and the technique works a little quicker on 45 because it's a little nicer. So I'm gonna use this coin to determine what curve this is, because that's what you want to do first. Is just guess that it's one of them and then test it and see if you're right or you're wrong. Okay. So we'll say heads it's f and tails it's f prime. Okay, so we're saying it's f. You can let Susie, or is dinner ready?
15 minutes.
15 minutes. Okay, I can do it. So y equals, I was going to tell him he could let Susie in. I had shut the door. The door's gone up, open and shut, because the cat cries and the kids are cooking dinner, which is really sweet of them. Okay, so we decided we would guess at that. Then what you want to do is you want to go everywhere where the derivative would be 0, and you want to verify that the other is crossing at 0. And so I want to, here the derivative is 0, because I said that this is f, right? So I want to verify that the derivative, because the derivative would be 0, and that I want to verify the other curve is at 0. And I notice that if I do that here, well, that's at 0. And I'm following along on f, and remember the derivative is the slope at that point. So I'm purposely picking these points that are 0, and well, it's 0. And that's all of them. And I'm like, okay, so does that mean that this one is for sure f prime? And it's actually better to see a contradiction than it is to see all agreement. And so I'm not convinced just totally yet. Now this right here is going uphill, which means the slope is positive. So all the way from here, all the way to here, the slope should be, the slope, because it's going uphill, is positive. That would mean that the other curve, if it was a graph of its derivative, would have to be from right here, would have to be all the way to here, would have to be above the x-axis. And you notice it's not. And because it would be positive, and a positive for the derivative would be above the x-axis, right? And so so now I know that the one that I guessed by flipping the coin was not right. I mean, it did have all the zeros in the right place, but it doesn't have that. And in fact, as I kind of go along here, I'm going downhill. And so that would mean from here, all the way to here, because I'm going downhill all the way to here, that would mean the slope is negative. That would mean this curve would have to be under the x-axis, but it's not. Okay, so what I want to do is I want to erase this being the derivative, the function, and I want to now guess, and I guess I got unlucky, I don't know. I want to now say that this one is the function. And remember, that's my first goal, is to figure out which one's the function and which one's the derivative. So now if I go on the little bit slightly darker one, and here is a 0, and that's at 0, and here is a 0, and that's at 0, and here is a 0, and that's at 0. Okay, from somewhere right here onward, this is going uphill, which would mean this would need to be above the x-axis. And you know that, notice that it is all the way to here, right? So uphill all the way to here, right? It's going uphill. Then it goes downhill, which means its slope is negative, so it means the derivative should be below the x-axis, and you notice that it is. So right here, the slope, m, is negative, and you notice that the other curve is below the x-axis, which would be negative, and so it is the graph of its derivative. And you can go through the whole thing, and you'll notice that everywhere that it's going uphill, this one is positive, and everywhere that it's going downhill, it is negative. And so it certainly does. I was trying to draw this right there on that 0, right here at the 0, and so that you could see going uphill, positive, and so yeah, it definitely works. So this one right here must be the derivative. Okay, then it wants us to compare f prime at -1. Okay, so if I go on the derivative, so I'm going on the derivative to -1, here's -1, typical Stewart graph, not labeled, right? And I am looking for the output. And when I come here at -1, and the graph that is the derivative is kind of the lighter, a little bit lighter graph, and it's at that height. They don't have any scale on it, but I do know, and I'm talking about the y value here, so I am talking about the height. And I'm kind of, I got this silly piece of paper here, but if this amount of room is 1, from here to here is 1, right? Then this height right here, and that's what I'm measuring as the height, it's a little more than half. And so at that point up there, and so this point right here at -1 is a little more than, because this distance was 1. So if I just use the same scale they had they have no scale on the y-axis, but if I just use the same scale on the y-axis as they had on the x-axis, then I'm saying that, it's definitely positive, but somewhere maybe 0.6, 0.7, something like that. Okay, now I want to compare, because I'm trying to find which one's bigger, right? And I want to look at what f double prime is at 1. So 1's labeled right here. So what I'm wanting to look at is I'm going to look at the slope of the derivative, because the slope, so I'm going to look at the slope of f prime. That would be the slope of f prime would be f double prime at x equals 1. So that's what I'm going to do. I'm going to come right here, and I'm going to go to the graph that we said was f prime. And so this graph right here is f prime. And I'm going to look at, and I'm not looking at the y value, I'm looking at the slope through that point. And would you agree with me that the slope through that point is roughly or exactly 0, right? Because it is on the place where it's the smooth turning point. And so they wanted to know which one was bigger, f prime at -1 or f double prime at 1. And one of them is equal to 0, and one of them some positive value around 0.7. So that's the bigger one. So f prime at -1 is bigger. So on this particular problem, I didn't even need to know which one was f. And so only if they would have just given me f prime, then I could have just answered the question from just knowing f prime. But since they gave me 2, I had to figure out which one was f prime, because you notice I used f prime to find all of the information. Then the next thing here, they're asking me to sketch the graph of this, and so this gives us more practice on our absolute value. So by definition, the absolute value of x is either x or negative x. So if I do this, g at x equals x plus the absolute value of x, then this is equal to, now just for the absolute value of x, do you all agree with me? The absolute value of x, I'm just looking at it, is either x or negative x. Is that okay? And well, either one of them, I'm going to add x onto that. So I'm going to say x plus, and I'm going to say x plus this, right? So I have x, I put the x right there, and then the absolute value of x is either x or minus x. And so then and the if for this is if x is greater than or equal to 0. And the if for this is if x is less than 0. I wish I wouldn't have written so big here. I did that again. I'm like chronic. I'm a chronic huge writer today is what I am. And so this is equal to g of x is equal to, I'm going to make it fit so that I have this room over here to graph it. X plus x is 2x. And see how I got stressed and then broke my pencil lead because of size. Why do you write so big? Well, I don't know. It's my habit. And then x minus x, x plus a negative x is 0. Okay, so I want to graph both of those because it asked me to sketch the graph. So I'm going to graph y equals 2x, and I want to pick values that are 0. When I pick 0, I get 0, and that was a borderline. You want to pick the borderline point, and it would be closed. And I'm going to pick 1 because I'm supposed to be bigger than 0, and so 1 is, and so this is 2. This is a line, so I only need 2 points. So 0, 0, and 1, 2. If I had to graph something, why didn't I give us a grid? I don't know. And then the other one that I need to graph, and so here's the line. I don't know why I didn't want to draw it, but I didn't. The other one is y equals 0, and that's a horizontal line. And a horizontal, if you want to pick points on it, you can. I was having some people came by my office and they were asking me how to graph a horizontal line. And so this says no matter what x is, including 0, y is 0. No matter what x is, including -1, y is 0. And so I can put those in. This would be open here because at 0 it was less than, but it's already closed by the other. And that typically happens when you use absolute value, so I'm not actually all that surprised about it. So there I have the graph right there, and it's beautiful. And I have writing right on my graph as well. It says, for what values of x is g differentiable? I stumbled on that today too, and that's not a word I usually stumble on, but today I did. So I'm looking at this and I'm like, well, you can find the slope of a straight line, it's 0. But the slope at a corner, that's undefined, right? Or does not exist. So that's a place where it's not differentiable. And then up here, it's all differentiable. And so the only place for what values of x is g differentiable. So it's not differentiable at x equals 0. So where it is differentiable would be from -infinity to 0, leave 0 out, and then 0 to infinity. So they were kind of asking, so differentiable. And so I kind of answered the question the opposite way. And so I'll make sure that everyone knows that I know. And so it's differentiable from -infinity to 0. I want to leave out 0. And then it's also differentiable from 0 to infinity. And then they asked me to find a formula for g prime. So I'm going to do that. Well, I have my formula right here for g. And so I'm going to say g prime at x equals, and then the derivative of 2x is 2. And so all here is where we're saying the slope is 2, the slope is 2, the slope is 2, right? And as long as this is if x is greater than, and I'm going to say or equal to 0 because I want to correct myself on that. Well, no, not at 0. 0 is where it wasn't differentiable. So I need to leave out 0. So, but as long as I'm greater than 0, the slope is 2. And then the derivative of 0 is 0. And so, and this is if x is less than 0. So over here, the slope is constantly 0. And that's what the derivative means, right? So all over here, the slope is constantly 0. At 0 itself, the slope's undefined. So that's why I don't have it defined to be anything here. And then over here, the slope is constantly 2. And there we did that. And so there was only 2 of them on the more examples for 2.2. So that's good news. And that took less than what they said dinner would take. So that's good.